Hey everybody, this is just a short video that I wanted to record as a follow-up to the Monty Hall forum that you just did. I would imagine that for most of you the results were pretty surprising because it's interesting, you know, if behind one of these three doors that I have here, I'll give these little doorknobs here, behind one of these three doors is a car. You kind of would think, well, okay, I've got a 1 in 3 chance of getting a car, and it doesn't seem like switching doors should really make a difference. But as all of you saw, when you simulated that a number of times, I think everybody got better results by switching than staying. And many of you got drastically better results by using the switching strategy rather than staying. And so I just thought I'd give a little explanation for why it actually does make sense that using a strategy of switching when given the opportunity is actually the better choice. So what we're going to do here is just pick one of the doors to be our initial guess. It doesn't really matter which, but let's just say this is my guess right here. Okay, so if that's my guess, then of course they are going to open one of these two doors, right, and reveal that to me, and then I decide to stay or switch. So let's think about what are the possible scenarios here. So on the one hand, the car could be here, which would mean a goat is here and a goat is here. Under the staying strategy, if you never move, then you get the car here, right, if you stay. And if you switch, then unfortunately you would get the goat, right? Because let's say the host opens this door, then you're going to switch over to this door here, and you're going to get a goat. So in that scenario, staying gets you the car, and switching gets you the goat. All right, but let's think about another scenario. Another scenario would be that the car is in the middle door, and a goat is in the first one. So if that happens, then if I stay on this door here, of course, I don't get a car, I get a goat. But if I switch, now here's the important thing. The host must open this door, right? They're not going to open a door and reveal a car. So they must open this door, which means that we switch over to the door with the car in it. So switching there gets me the car. And then finally, the only other scenario is where the goat is in door number 1, door number 2, and the car is in door number 3. But again, that's exactly what just happened. The only difference is if the host has to open this door, and so then you're going to pick this door and get the car, and then of course if you stay, you're going to once again get the goat. So if we just think about the 3 possible things that could be happening, we can see real clearly that 1 out of every 3 or 1 out of the 3 scenarios gets you the car. And here, 2 out of the 3 scenarios gets you the car. So that's why switching is the best strategy. Now, 2/3 is about 0.67. So now if you think about the results that you got when you tried the different strategies multiple times, some of you might have gotten really close to 0.67. Others of you may still have been a decent amount of the way off of this. But understand that what's going on there is that while I had you do it a number of times, I didn't have you do it quite enough times for us to be able to really observe what's called the law of large numbers going into effect. So just to kind of look at this, right, we know that theoretically the switching strategy should yield a win about 2/3 of the time. So I'm going to repeat the switching strategy 10 times, okay? So I hit go, and you can see that this is, bouncing around here. So after 10 times, I'm at 70%. Actually, quite good, right? If I do another 10 times, it keeps going. All right, 70% again. All right, but then I'm gonna, let's see, uncheck animation here. Let's do this 1,000 more times. And you can see what's happening here, right? It's really getting itself settled down. It gets 66 point something percent. And so remember what it is for us, it's 66.7%. So we are getting really, really close. And if I did another 1,000, right? Now we're at 67%. And so the law of large numbers says if you repeat a process over and over again, then as the number of times you repeat it gets higher and higher and higher, the percentage of the time your observation occurs should approach what you would expect theoretically. Okay, and we can see that. So lots of variety right at first, but then it'll settle down to that theoretical probability of this is about 2/3 and this is about 1/3. So switching gets you a win 2/3 of the time and a loss 1/3 of the time.